Hello, this is Jacob. As the AI coder is getting popular, so today I'm gonna make a video on the one of the very popular open source options. It's called DeepSeek Coder version 2. Hopefully you will enjoy this episode, and let's get right into it. So still the same, open your Kaggle.com notebook and create a notebook called DeepSeek-Coder-V2 or any name you want. Then we need to first set up a few things. So we need to write a function. Basically, it will run a bash command in Python environment. And then next, we'll basically use Olama to fetch the model. So if you don't know what Olama is, check out my previous videos. So basically, it's a it's a very popular way or the most popular way to um, use any open source models on the local environment. Um, so yeah, so let's just use Olama for demo purpose, and also just use Olama for just for this notebook. So we basically use Olama and installation script. So I'll install Olama automatically. Then we need to make Olama run more stable because Kaggle has some issue with Olama server, so sometimes it will shut it down. So to make this stay work all the time, so we'll use supervisor for that purpose. So we basically do a supervisor install via apt, or you can do that via pip as well. So either way works. Then we will basically check out if supervisor is installed, and then basically just create a configuration for Llama service. So we set up the environment and also set up the command to start up the Llama server. So this is all basically from Llama's official document. So you can check the llama.com to figure basically what the best command is. So we just use the default one, Llama serve. So we also make sure that when there's an error, it will auto start and auto restart, and then we basically get the error and regular output logs. So like that. After we set up the configuration for supervisor, then we just do a uh, basically restart and also the start or reload if there's any configuration changes. So we can actually then check the Llama service logs. So the service is running. If you can see the logs basically is running, and so we just check the status for Llama service. So it shows it's running, and um, basically just download the model since Llama is running, and we just download the model. So DeepSeek Coder version 2. So we just download that. DeepSeek provides a few different models categories like DeepSeek Standard, DeepSeek Instruct, DeepSeek Coder, or DeepSeek Math. So this demo is for DeepSeek Coder. So the latest one for Coder, I think, is V2. They just released a DeepSeek 2.5, but that's not the Coder version. So just keep in mind. So right now we're just doing the DeepSeek Coder version 2. After that, we just check out the model if it's actually wired up in Olama. So you can see it's actually in the Olama. So and it's about 9 gigs. So Olama has, the Kaggle has 16 gigs VRAM if you use P100. So it should work. That's why we actually choose Kaggle for this purpose. Um, by the way, Collab from Google probably will not work exactly if the model gets bigger because Collab has a little bit less VRAM. It has probably less than 16 gigs because it's used a regular T4. So, but just keep in mind, Kaggle have a P100 16 gigs VRAM for you to use. And then after that, we just do a ngrok installation because Kaggle doesn't really work with Gradle that well. So we use ngrok instead. So ngrok can actually route the public traffic to your local notebook. So um, we'll demo that in a little bit. So basically, if you run a notebook on Kaggle, it will just spin up the service, but it's internal, so it's not public. And if you want them be publicly accessible, then use ngrok. Gradle is supposed to do that, but Gradle doesn't really work very well with Kaggle. So that being said, so let's continue. So after we install all these ngrok dependencies, what we do is basically get the auth token. So go to the ngrok user console, then you can grab the token, paste it here. So just we'll execute this block. It'll basically pop up a input, so you can enter that grok token. So it's saved in the default configuration path for ngrok. So you can check out if that is actually be configured. Just run this cat command. After that, we just spin up ngrok. I just do because this demo is using Gradle. Gradle is on port 7860, so ngrok is pointing to that port. So when ngrok is spin up, then it will route the traffic from public to the local host 7860. And so this is a public URL, and then we'll check that out in a bit. So this is basically you can actually use browser to play around with the this service or the model. So so this is all the basic setup we have to um, do for Olama, um, but Olama doesn't give you sort of like a very easy, accessible UI. So in that case, we just use Gradle. You can use other UI, web UI tools as well, but right now we just use Gradle for demo purpose, and we use Olama library, so you can install both. Um, you're just using pip. So a good um, tool for Olama Gradle integration is from YCYY, and then from this link you can check the repo. So just only a few files. So this will actually integrate your Olama with Straka Gradle interface. So then it's very easily accessible from public. You'll see that in a bit. So let's go back to Kaggle Notebook. So this is all their Straka configuration. So if you look at the YCYY Olama Gradle Web UI repo, so you see basically they have essentially three files: the FPY, prompt, and the requirements. So the requirements basically is the dependencies we saw. So you can see that actually the just Gradle and Olama. And the prompt is basically it's just a few lines of configuration, and just also put that into this Kaggle working environment. So it basically will write to the Kaggle working directory, and so this the configuration for the YCYY, Gradle, Olama, and project. So then you also want to write this file. So because we didn't actually download the YC YY Olama Gradle repo, so we just did a sort of like just copy and paste everything to Kaggle environment. You can also do an install as well. So after all the code is in Kaggle, so all you have to do is just run Python app.py. So essentially, it's gonna spin up the Gradle environment and connect to your Olama server on Kaggle. Um, so you can see it actually spin up on the 7860 port. And if you go back to the um, uh, ngrok setup, then you will see this is the URL you can access publicly. So let's go to this URL, 23 and 79. So then you basically have this live and accessible from public network. So this is pretty good. It's awesome. And so you can actually see this is the a DeepSeek model we downloaded from Olama, and so you can also download multiple models to try them all out. For this demo, we just do the DeepSeek-Coder version 2. We um, basically try to just test a few things for the DeepSeek auto coding framework or auto coding model, then we just test all these test cases. The first one to test is Fibonacci sequence generator, and basically just write a function in Python that generates the first n numbers of the Fibonacci sequence. So if you check this out, so we did this before making this video, so just for time purpose, but you can check this out. So this is the actual output for Fibonacci function. So this actually looks correct. And then this is output from the function. So you can also paste that into a notebook or local environment to test that out, but this looks good. So the other test we want to see is to implement a quicksort algorithm in Java. So if you look at this one, you see there's actually just add a prompt from the bottom, um, enter it here. So basically start coding. If you see the quicksort function, you start a static void main function, and then basically just run quicksort. This is actually pretty good. So just if you have a Java environment on local machine or you have an online version or online tool, you can try them out. You feel free to just copy and paste code to try them out. Here's an explanation for the quicksort. So all each functions, what it does, it's very good. Um, and then the third one we want to test out is basically create a, a query function in the Node.js. So basically create a simple RESTful API in Node.js using Express framework that perform these basic CRUD operations for a product resource. So, and this is basically what it come up with. So it basically tells you how to start up the environment, do a make directory, and then do API init, and then do a dependency install. Then you start create a Node.js function, the server.js, and it looks good. So it also kind of tell you how to run the server, the server.js, and then you how to run each of the endpoints. Like you list all the products, or you basically try to get a specific product or update a product, and then how to delete product. So very good. And also this has all the explanations for each endpoint, what each endpoint does. So this one is good too. And then another test we want to run is for the SQL query. So if you look at the SQL query for, let's say, write a SQL query to find the top 5 customers who spent the most money in last year. So this is the query, right? So we want to basically write a SQL query to serve that purpose. So here's a query it come up with, and you have the breakdown of the query, what each query does. Very good. So uh, the other test case we want to run is called basically machine learning model training. It's train a simple linear regression model using Python's scikit-learn library to predict house prices. And then here's that function or the piece of code that it come up with. So it has it's the first dependencies. You need NumPy, pandas, and the scikit-learn library. And then here's the function. And also explains everything that it built. This is really good. So um, for all these basic test cases, we have be able to successfully run them in the DeepSeek Coder version 2. So which proves that it's a very solid open source model. Another couple of things I want to test is for how it can correct errors in the code. For example, we want to basically type in something incorrect and then see if it can correct it. So for this example, we want to say, okay, we purposely I just misspelled some of the command line. So basically, you see the pip install, we just do a pip ist. So to let the AI coder to see if there's anything wrong with the code. So actually, they correct it right away. So basically, the command you provided, pip install numpy and pandas and scikit-learn, you should correctly install the specific packages. However, it's a good idea to check if everything is set up properly on your system before installing any Python packages. So, and ensure PP is upgraded, and also tell you also spin up a virtual environment, and also this is the right way to install the packages. So excellent. So this is actually excellent explanation of what the code went wrong and how you should do it. So the second test cases is that we want to basically correct the SQL query that we generated earlier, right? So we just purposely made some errors in the group by clause, and then we made some errors in the limit clause, and we didn't tell you which database it is. Maybe it's a MS SQL, Microsoft SQL, or it's a MySQL, because limit doesn't apply to Microsoft SQL. In Microsoft SQL, it's a like select top, right? Select top 5 or top 10 or something. So and we just let the deep security check if there's anything wrong with the SQL query. So if you look at the explanation, he actually did a pretty good job. Like you have a group by clause incorrect, and then you should correct it as group by. And you basically, the word limit used to be a specified number of results is specific to certain databases like MySQL, exactly, and not standard SQL like MySQL, Microsoft SQL. So because Microsoft SQL, it basically is like top 5. So, it tells you like the order by is incorrect because actually we made uh, incorrect spelling purposely. So it's DS is DSC. So it also found that it's incorrect. So it let us to correct it. And here's the correct. Also basically tells you like here's the correct version of your SQL query. Excellent. This did a fantastic job. So overall, I think DeepSeek is really good AI coder. It's open source and helps a lot of the coding issues. So after a basic test, it's very solid. So that being said, hopefully you enjoy this video, um, and hopefully that helps. Um, yeah, please leave your comment below, and see you in the next video. Thank you so much.